#SilentWatchers. As dawn breaks over the African savanna, a network of silent observers springs to life. Microscopic sensors activate in the soil, thermal cameras track movement through the canopy, and high above, satellites monitor patterns invisible to the human eye. We have entered an age where technology allows us to witness nature's most intimate moments, revealing behaviors and patterns that have remained hidden for millennia. But these artificial eyes and ears have recently detected something extraordinary, a phenomenon so unexpected that it challenges our understanding of how life on Earth communicates and adapts. What began as isolated anomalies in animal behavior has evolved into a global pattern that defies explanation. The surveillance network. Imagine a neural network spanning the entire planet. Thermal imaging drones track elephant herds through the night, while smart cameras hidden in tree canopies monitor primate behavior. Underwater sensors record the movements of fish schools, and satellite systems track bird migrations across continents. Each device is part of a vast artificial intelligence network that watches, learns, and identifies patterns in wildlife behavior. This technological web has transformed our understanding of the natural world. We can now track individual animals throughout their lives, understand complex social interactions, and predict movement patterns with unprecedented accuracy. But recently, this network of artificial observers has detected something that shouldn't be possible: synchronized behavior patterns emerging simultaneously across different species and continents. First signs. The first indicators appeared in the African elephant herds. These magnificent creatures, known for their complex social structures and traditional migration routes, began exhibiting unusual movement patterns. Family groups from different regions, with no direct contact, started moving in synchronized ways, as if responding to an unseen signal. Our AI systems, processing data from thousands of monitoring devices, identified something remarkable in these movements. The elephants weren't just changing direction, they were moving with mathematical precision, their paths forming complex geometric patterns when viewed from above. These weren't random wanderings. They were deliberate, coordinated changes that suggested a level of communication we never knew existed. Global patterns emerge. As we expanded our analysis, the phenomenon grew more intriguing. In the Arctic, caribou herds began altering their migration routes in patterns that perfectly mirrored the elephant movements, despite being separated by thousands of miles. Wolf packs in North America adjusted their hunting territories in corresponding ways. Even underground, burrowing animals modified their behavior in harmony with these surface changes. The precision of these movements defied conventional explanation. Different species, separated by vast distances and environmental barriers, were moving as if choreographed by an invisible conductor. Our AI systems, analyzing millions of data points, confirmed that these changes couldn't be coincidental. The mathematical probability was virtually zero. Technological innovation. The technology that enables us to witness this phenomenon represents a quantum leap in environmental monitoring. Advanced machine learning algorithms can now process visual data from thousands of sources simultaneously, identifying subtle behavioral changes that human observers might miss. Quantum computing systems analyze complex movement patterns in real time, finding correlations across species and continents. Consider how a single elephant herd is monitored. Thermal drones track their body temperature and movement patterns, while ground sensors detect their subsonic communications. Satellite imagery provides a broader context, showing how their movements relate to environmental conditions. AI systems integrate all this data, creating a four-dimensional model of animal behavior that reveals previously invisible patterns. The hidden network. As our artificial intelligence systems processed more data, a startling possibility emerged. These synchronized behaviors suggested the existence of a natural communication network that operates beyond our traditional understanding of animal senses. Somehow, species across the planet were sharing information about their environment and coordinating their responses. Think of it as Earth's original internet, a vast web of communication that doesn't rely on technology but on the intricate connections between living systems. Our AI monitoring networks weren't just observing this system. They were helping us decode it for the first time in human history. Deep learning insights. Through deep learning analysis, we've begun to understand the complexity of these behavioral patterns. When we map the movements of different species onto a global scale, they form intricate geometric patterns, like a planetary dance choreographed to rhythm we're only beginning to hear. Each species contributes its own movements to this dance, creating a symphony of motion that spans continents. The AI systems have identified several key characteristics of these patterns: perfect synchronization across vast distances, mathematical precision in movement geometries, cross-species coordination without direct contact, temporal alignment with environmental changes, predictive responses to future conditions, environmental connections. As we delve deeper into these patterns, their relationship to environmental changes becomes clear. Species aren't just moving in synchronized ways, they're responding to environmental signals that our instruments can barely detect. The AI network has observed animals beginning these coordinated movements days or weeks before our scientific instruments detect any environmental changes. This suggests something remarkable. The natural world maintains its own early warning system, a network of living sensors that can detect and respond to environmental changes long before our technology can measure them. We're witnessing an ancient system of environmental monitoring that has evolved over millions of years. Behavioral adaptations. The sophistication of these behavioral changes is stunning. When we analyze the movement patterns in detail, we find that each species adjusts its behavior in ways that complement the actions of others. Predator species modify their hunting patterns to maintain ecosystem balance. Herbivores adjust their grazing routes to prevent overuse of resources. Even insect populations shift their activities in harmony with these larger patterns. Our AI systems have documented countless examples of this coordination. Bird flocks altering their migration routes to avoid areas of future disturbance, marine mammals adjusting their feeding patterns in response to upcoming changes, plant pollinators modifying their behavior to maintain ecosystem balance, soil organisms changing their activity levels to prepare for environmental shifts. Technical challenges. Monitoring these patterns presents unprecedented technical challenges. The sheer volume of data generated by our global surveillance network requires new approaches to processing and analysis. We've developed specialized AI algorithms that can identify meaningful patterns within the noise of millions of daily animal movements. Quantum computing systems play a crucial role, processing complex behavioral data in ways that traditional computers cannot. These systems can analyze the movements of thousands of species simultaneously, finding correlations and patterns that would be impossible to detect otherwise. Future implications. As we continue to monitor these patterns, their implications become more profound. We're not just observing animal behavior, we're witnessing a global system of environmental intelligence that has evolved over millions of years. This system appears to be far more sophisticated than our own environmental monitoring networks. The question now becomes, can we learn to work with this natural system rather than simply observe it? Can our technology help us become active participants in Earth's environmental intelligence network? Current research, recent advances in AI analysis have revealed new layers of complexity in these patterns. We're finding that the synchronized behaviors aren't just responses to current conditions, they appear to be anticipatory, preparing for environmental changes weeks or months in advance. This suggests a level of predictive capability that surpasses our most advanced forecasting systems. Human integration. As we develop our understanding of these patterns, we face crucial questions about humanity's role in this global system. Our technology has given us unprecedented insight into nature's communication networks, but we're still learning how to interpret these messages correctly. Looking ahead, the patterns we're observing continue to evolve, suggesting that we're witnessing only the beginning of a larger phenomenon. Our AI systems predict that these synchronized behaviors will become more pronounced in the coming months and years, possibly indicating significant environmental changes on the horizon. Conclusion. As our silent watchers continue their vigilant monitoring of Earth's wildlife, they reveal a world far more connected and coordinated than we ever imagined. Through the lens of artificial intelligence, we're beginning to understand that what we once thought of as separate species acting independently is actually a vast, interconnected system of life responding to changes in our planet's conditions. The technology that allows us to witness these patterns isn't just a window into nature's behavior, it's becoming a bridge between human understanding and Earth's ancient systems of communication. As we continue to watch and learn, we may find that we're not just observers of this global phenomenon, but potential participants in Earth's environmental intelligence network. End of episode 2.